Hello friends, it's your NOLA Mathman here again for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
After watching this video, students will be able to solve trigonometric functions and right triangles. The concept we're looking at is trigonometric functions. The skill we're looking at is evaluating them in right triangles. So with no further ado, let's get started with section 12.1. So in this first example, we're going to find the values of 6 trigonometric functions for angle theta. We have to first label the sides of a right triangle. The side opposite theta is called the opposite, that is 8 in this problem. The side next to the theta is adjacent. The term we're looking for, because we don't have the longest side, that's the easiest side to label, called the hypotenuse. So we have to find that side C. We use the Pythagorean theorem, a squared plus b squared equals c squared. We substitute a is 6, so we substitute 6 for a. We substitute 8 for b, and we solve for c. So we have 6 squared plus 8 squared equals c squared. 6 squared is 36. 8 squared is 64. You add them together, you get 100. You take the square root of both sides to get c. C is going to equal 10. And so our hypotenuse is 10. So at this point, we could start solving the 6 major trigonometric functions that you will get familiar with. The more you do, they'll be second nature by the time we're done. So we'll start with sine theta. The rule for sine theta is opposite over hypotenuse. That's the ratio. So since the opposite is 8, we put 8. The hypotenuse is 10. 8 over 10 simplifies to 4/5. So our sine theta is 4/5. Cosine, the formula is adjacent over hypotenuse. We substitute those values in, we will have 6 over 10. We reduce those values, we will end up with 3/5. So the cosine of theta is 3/5. The next major trigonometric function is tangent theta. That is opposite over adjacent. As you can see, you always want to write the formula. The opposite is 8. The adjacent is 6. 8 over 6 reduces to 4/3. And so tangent theta is 4/3. So now we're going to do what we call the inverse of the 3 that we just did. The cosecant is the inverse of sine. So it will be hypotenuse over opposite. So we flip over 8 over 10. That'll be 10 over 8, which reduces to 5/4. So then we'll do secant, which is the inverse or reciprocal of cosine theta. And that will be hypotenuse over adjacent. That will give us 10 over 6, and 10 over 6 will reduce to 5/3. And then our last inverse one, or reciprocal, is cotangent theta, which is the inverse of the tangent. That will give us adjacent over opposite, which is 6 over 8, and that reduces to 3/4. And so we have now found our 6 trigonometric functions for our angle theta for this problem. So we're done with number 1. So again, the more you get used to it, the easier it becomes. You always want to write the formulas down for each of the trigonometric functions that we deal with. So we did number 1. What do you think we're going to do next? What kind of problem do you think the NOLA Mathman is going to do? I'm going to get rid of 1 here, and we're going to bring in another problem here in a second, which should show up any second. Okay, we're going to do number 3 now. So now we have a triangle where we're given the opposite and adjacent side again. This time our opposite side is 3. Our adjacent side will be 2, where again we have the hypotenuse, which is unknown. So just like the first problem, which this kind of follows the same format, we have to solve for C. So we set 2 equal to A, we set 3 equal to B, and we're going to substitute it into the Pythagorean theorem and solve for C. So in this problem, A is 2, so we will put 2 squared plus B, which is 3. We substitute 3 there, 3 squared equals C squared. 2 squared is 4, 3 squared is going to be 9. So C squared will be equal to 13, which is the sum of 4 and 9. Take the square root of both sides, and C is equal to the square root of 13. The reason that why NOLA MATHMAN picked this is we wanted to get a value of C that was not an integer. This is more like a rational number. So we want to see how that affects our trigonometric values. So we have C now. Now we start to do our trigonometric values here. We start with sine. Sine theta will be what again? Do you remember? It's opposite over hypotenuse. We substitute those values in. That will be 3 over the square root of 13. Now what you learned, you should learn in algebra 1, you cannot have a square root in the denominator. So we call this rationalizing the denominator to get rid of the square root. We multiply both the numerator and denominator by the square root of 13. That will give us a product of 3 times the square root of 13 over 13, because when you multiply 2 square roots, it gets rid of the square root and makes your denominator an integer. So again, we do adjacent. We substitute the values. We have 2 over the square root of 13. Again, we have to rationalize that denominator by multiplying both sides by the square root of 13. And we will end up with 2 times the square root of 13 over 13. So now for tangent theta, we have opposite over adjacent. Both of those are rational numbers, so we will end up with a value of 3/2, which cannot be reduced. So now we will do our inverse or reciprocals of the 3 original trigonometric functions. Cosecant is the inverse of sine, so we put hypotenuse over opposite. That will be the square root of 3 over 3. Since the denominator is 3, we can keep that as an answer. Secant theta, we reverse cosine. We'll have hypotenuse over adjacent. That's the square root of 13 over 2. Again, since your denominator is a rational number, we can have that answer and we leave it like it is. And then for cotangent, was the inverse of tangent, we will have 2 over 3 as a value, which is the reciprocal of 3/2. So we have gotten our 6 trigonometric functions, even when we have a C term that is a rational square root. So we've done another problem. So we're on our way here. So we've done 2 problems where we've had to identify the 6 trigonometric functions for angle theta. So now we're going to look at another type of problem. Looks like we have different type of problem that's about to come up. While we're waiting for that, you want to kind of review over your 6 trigonometric functions. So now we're going to do some problems that take into practice the rules of trigonometric functions. Problem reads, in a right triangle, angle A is acute. So we're going to do number 4 that states, if tangent A is 3, what is sine of A? So we know tangent of A, the formula is opposite over adjacent. So if A is 3, we can put the opposite is 3 over 1. Because 3 over 1 gives you 3. So we're going to make the opposite side 3. We're going to make the adjacent side 1. We draw a right triangle. I should have put the little, NOLA MATHMAN should have put the little square indicating right triangle. And now we have to solve for C like we've been doing. So we substitute 1 for A, 3 for B, and we will solve for the hypotenuse. We will have 1 squared plus 3 squared equals C squared. 1 squared is 1, 3 squared is 9, so C squared is equal to 10. Take the square root of both sides, and C is going to equal the square root of 10. Now, since C is equal to the square root of 10, we have the formula, so to speak, the components for sine, which is opposite over hypotenuse. So we're going to write that formula there, and we're going to substitute the opposite of A, which is what? What do you think that is? You're correct, it's 3. And we will put 3 in the numerator, hypotenuse is the square root of 10. We know we cannot have an answer with a square root in the denominator. So we have to multiply both the numerator and denominator by the square root of 10 like we did in the last problem. And we will get a final answer of 3 times the square root of 10 over 10. And that is what sine A is equal to. So we are done. And again, we want to circle our final answer, which is always a good practice to use when you do your math problems. So we did that. Number 4 was an interesting problem where we used our components and knowledge of the 6 trig functions to solve. So now, what do you think we're going to do? What's the NOLA Mathman going to do now? What kind of problem you think we're going to do now? Well, I'm sure it's going to apply concepts involving the 6 trigonometric functions. So now we got a problem where the directions read, use a trigonometric function to find the value of x, round to the nearest 10th if necessary. So they give us a right triangle, and we have to solve for x. So the first thing we have to do in our problem, theta is 30 degrees. So we have to figure out what the type of sides we have in relation to 30 degrees. The 8 is opposite 30 degrees, so we label that the opposite side. The x is next to 30 degrees, so we label that the adjacent side. What trig function has opposite and adjacent? That's what we're going to use to solve for x. Tangent has opposite over adjacent, so we put tangent 30, opposite over adjacent. We substitute the values for opposite and adjacent, so we will have, now we know that the tangent of 30 degrees is the square root of 3 over 3. So we substitute that value in, because you can't have 2 unknowns. We know we have an unknown of x. So we put 8 over x, we substitute 8 for opposite, x for adjacent. So now using the concept of proportions, we cross multiply. We end up with x times the square root of 3 equals to 8 times 3. We divide both sides by the square root of 3 to get x. And x is going to equal 8 times 3, which is 24, over the square root of 3. And you get a calculator and divide that, and x is going to equal approximately 13.9. Again, if you get your calculator, you will see that's the answer. So we have solved for 6. Good job. So let's see what we're going to do next. Look like we'll probably solve another problem with x in it. We have a right triangle, that's correct. We'll do number 9. So we have another right triangle. This time our theta is in the top of the triangle at 60 degrees. We have to label 5 and x in relation to 60 degrees. Now you know x is going to be opposite because it's opposite 60 degrees. 5 represents the longest side of the 3-sided triangle, so we know that's the hypotenuse. So what trig function has opposite and hypotenuse? Yes, you're correct. It's sine. I knew y'all knew that since we did it earlier. So we put sine of 60 degrees is opposite over hypotenuse. Now again, the sine of 60 degrees I will give for you, but you can look that up in the table usually in your textbook. It could be on your calculator, you can use it, but that will be equal to square root of 3 over 2. It's a special triangle. They have books that have that. And so we will substitute the square root of 3 over 2 for sine 60 degrees. Opposite, we will put x. And again, what I'm doing is showing you how you get the value of the square root of 3 over 2. You draw a right triangle, we call it a 30, 60, 90 triangle. The shortest side is x, the longest side is 2x, the middle side is x times square root of 3, and that will allow you to get that answer. So we substitute square root of 3 over 2 for sine 60 degrees. We put x over 5, representing the opposite of the hypotenuse. We cross multiply, and we get 2 times x equals 5 times square root of 3. Divide both sides by 2 to solve for x. You get your calculator, you solve it. 5 times the square root of 3 divided by 2 will get you a x value. Let's see what we get here. Get your calculators. You should be calculating while the NOLA Mathman is calculating. It takes a little time for the NOLA Mathman to come up with it. But yeah, you have a good calculator. So yes, here we go. Value for x will be 4.3. And so we've done another right triangle where we use trigonometric functions to solve for x. Very good. So we've done 2 of those type problems. Let's see what we're going to do next. What do you think the NOLA Mathman is going to do next? Let's see. So we'll move that out the way and bring up another problem. We have the same directions. We'll do another right triangle with x. Let's see. Oh, we do. So we have here another right triangle. Again, our theta is at the top of the triangle. It's 51 degrees. We're given 8 and x is 2 sides of the 3-sided right triangle. We have to label those sides. Since x is next to 51 degrees, we know that's the adjacent side. Label that. Since 8 represents the longest side, we know that's the hypotenuse. So what trig function has adjacent hypotenuse? You're correct again, it's cosine. So we go cosine of 51 degrees is adjacent over opposite. We substitute those values in. 8 over x and 8. We will solve for x by multiplying both sides by 8. X is equal to 8 cosine 51 degrees. You get your calculator. You plug that in, cosine 51 degrees, you multiply by 8, you end up with an x value of 5.0. And so that is your answer. So we've done yet another example where we're using trigonometric functions to solve for x. And again, every problem has a different trig function based on the sides given. That's the key to determine which one of the cosine or sine or tangent we will use. You have to label your sides. And the more you do that, the easier it becomes to identify the correct trigonometric function to use. So it looks like we're done with those problems. So now we're going to find the value of x round to the nearest 10. Now we found the value of sides. Maybe in this group of problems, the NOLA Mathman will find x degrees. We haven't found the measure of angles in the right triangle for theta. So maybe that's, oh look, that's what we're doing. So in this problem, we have a right triangle, but this time, instead of finding the length of a side, we're looking for the value of theta in this problem, which is x degrees. So again, like we did in the last problems, we want to label the sides in relation to x. X theta, the 4 is going to be adjacent since it's next to it. 5 represents the longest side, so it's the hypotenuse. So again, what trig function has adjacent hypotenuse? It's correct. We're going to use cosine. So we write cosine of x degrees equals adjacent over hypotenuse. We substitute our values in. That will be 4 over 5. So x degrees theta will be equal to, and this is the first time we're using this when we're looking for angles, we use inverse trig function. So we have the inverse cosine of 4/5, which again, you have that function in your calculator. Get your calculator out, you take the cosine, inverse cosine of 4 over 5, and you will get a total of 36.9 degrees for x. And so that's what you get. All right, very good. So let's try another one like that, because again, this is different than the problems we've been doing. We've been looking for sides. So now we're looking for angles. So let's try another one of those. So now we're going to do number 13. We have another right triangle. We're looking for x degrees. We're given 2 sides, 7 and 13. So what do you think we're going to do first? Well, we have to label the sides. 7 will be opposite since it's opposite x degrees. 13 is a hypotenuse since it's the longer of the 3 sides. What trig function has opposite hypotenuse? You're correct again. It's sine, so we're going to use that formula to solve for theta, or x degrees. We put sine x degrees opposite over hypotenuse. We substitute those values in, 7 over 13. X degrees will be the inverse sine of 7 divided by 13. You get your calculator out, you solve it, and your X will be, go ahead and calculate it, see what you get. We're waiting. NOLA MATHMAN is putting it in the calculator as we speak. It takes a minute. And so it should pop out a theta that will be our degrees for this problem. Let's see. It's taking a little longer than we thought here. This is not. Oh, there we go. We have 32.6 degrees, and that will be our theta for this problem. And so we're done with another one there. Very good. So we've done 2 examples where we had to find the value of the angle, the missing angle. So we get rid of number 13 there. Got another problem. We'll do a third problem. The more of these you do, the more confident you'll get. So we have another right triangle. We're looking for theta at the top of the triangle. We label the sides. 2 is adjacent, 15 is opposite. So what trig function has opposite and adjacent? You're correct, it's tangent. So we have tangent of x degrees equals opposite over adjacent. We substitute our values in for opposite and adjacent. Tangent of x degrees is 15 over 2. X degrees will be the inverse tangent of 15 over 2. So that should pop up here in a sec. And the -1, that's the indicator of inverse function. You get your little calculator out, you plug in inverse tangent of 15 over 2, and you will get the number of degrees that is, which will be 82.4 degrees. We are done, we've done, and so we're at the end of our math adventure in regards to this concept. After this lesson, you should be able to solve trigonometric functions and right triangles. So we have been very successful at our math adventure. And until we meet again for another math adventure, this is the NOLA MATHMAN signing off. Have a blessed and prosperous day.